Hey everyone, and welcome to the Math 1 LS3 computer programming tutorials. In this video, we're going to learn about limits and differentiation on Python. So this is the second lab. Make sure that you're working on the correct file. You can go to the online assessment tool to enter all your answers. You can click on the link to access that. To begin, run the first cell and make sure that it runs. The first part of this assignment is about constructing a table of values. You can do this by defining x as np.linespace of a, b, n. This gives you a list of n equally spaced values between a and b. You can define any y that you want, for example this function, using the tables of values that you've constructed using x. You can print these to see what you have in each table of values. You can also print ordered pairs. Keep in mind that Python stores positions at 0, so x0 would give you the first item in the x table. Instead of doing this manually, you can construct a for loop that goes from 0 to n, which is the number of points on your table, and prints every x and y for you. This gives you a list of ordered pairs, so at each x, what is my y? We can print this to see the results. You can also use the code in this cell to align your table. Finally, we can use what we have learned from these three cells to construct a table of values for this function. If you remember from previous labs, for loops are constructed this way. I goes through this range from 3 to 8, not including 8. This loop just prints them. It goes from 3 to 7. You can also do mathematical operations on the values of a loop. For example, this one raises them to different powers. You can see the printed results here. Make sure that you understand what indentation does. For example, in the first loop, I love math is printed every time we go through the loop. However, in the second one, I love math is only printed once after the loop is done. You can find the limit of a function by building a table of values for it. Remember that when you're approaching a value, you have to get really close to it. So for example, when you want to approach 0, your x values have to be very close to 0. They have to be slightly above and slightly below 0, and your y values at those points would be your limit. You can increase your n to get values that are closer to the value that you're approaching. Alternatively, you can make a and b closer to the value that you're approaching. Using any of these methods, you're going to get a more accurate result. We can solve different equations using the intermediate value theorem on Python. In short, this theorem tells you that if a continuous function goes from a negative value to a positive value, there must be an x value on which your y value becomes 0, and that is the solution. Similar to the method that we use to find the limits, you can find the solution when your y value changes signs. So for this case, it will be between 3.2 and 3.3. You can use any of the methods mentioned there to make it more accurate. An easier method would be having Python finding that interval for you automatically using a for loop. You can use this for loop in different questions. This for loop selects small intervals, and it checks to see if the left point of the interval or the right point is a solution. It also tells you if the solution is between the points. In this example, the solution is between 3.2 and 3.3, similar to what we saw earlier. Just like the limits, you can make this more accurate by magnifying the a-b interval or increasing n. We can use if for conditional statements. Make sure to use this formatting for your if statement. If this statement is true, the computer is going to do what's indented, otherwise it is going to skip the codes. You can also use if statements in a for loop. Each value of a loop goes through the if statements, and the true conditions will be printed. Alternatively, we can add an else statement. So if the if statement is untrue, it can go through the code for else. For example, I entered the temperature as 10. Since the if statement is untrue now, it goes through the code that is written for else. You can find the derivative of a function on Python using this method. You need to rewrite this equation in terms of your own function and define it as a new variable such as y prime. Another useful code is np.max. This gives you the maximum value of a list or a table of values. For this question, the data points have been imported, therefore we cannot define a function that calculates the rate of change. In this case, we can use the actual data points and find the rate of change between each two consecutive data points. We can add this rate of change by the append command to the empty list of conc prime. We now have a rate of change list for these data points. Finally, using all the techniques that we learned in this lab, we can find the critical numbers of a function. In order to do that, we need an x table, a y table, and a y prime table, as you learned in the derivative section. You can find where this derivative becomes 0, as you learned in the intermediate value theorem. By using these codes, you can find all the critical numbers on the interval. Thank you for watching, and let us know if you have any questions.